Rahim and Assalamu alaikum. My name is Dayan Rafiq and I am a foundation level student at Rehan School Islamabad Barapur campus. Today I am going to conduct an AI session with Maya. In this session I will ask two questions and Maya will provide the answers. So let's start.
All's in your court.
Maya, my first question is, what is software?
Software is essentially the set of instructions that tells hardware exactly what to do. It's the invisible logic, the mind of the computer as opposed to the hardware, which is the physical body. Think of it like a musical score for a piano. The piano itself is the hardware. It's the wood, the wire, and the keys. It's a physical object you can touch. But the sheet music, the notes written on the page that tell the pianist which keys to press and when, that's the software. Without the music, the piano is just 20 years old. What are we talking about exactly? Is that the piano from this story or something else entirely?
Okay, my next question is, what is the difference between software and hardware?
Right, let's get into it. At its core, the difference is a matter of physical substance versus logical instruction. Think of hardware as the body and software as the mind. Hardware is everything you can actually touch and feel. I'm talking about the circuits, the hard drive, the screen, the keys of a keyboard, and even that fan that starts humming when your computer is working too hard. These things are made of physical materials like silicon, plastic, and metal. They are tangible. They can wear out over time, and you can physically replace them if they break. And wafers in the processor, the copper wiring on the motherboard, the magnetic platters in an old hard drive, or the flash memory cells in an SSD. It's the actual tangible matter that takes up space in the physical world. You can touch it, drop it, or feel it get hot under your fingertips. Hardware is the vessel, but it's fundamentally inert. It's just a collection of switches and circuits waiting for a signal to flip. Doesn't know how to do anything on its own. It just provides the physical capability to execute a command. Software, on the other hand, is the ghost in the machine. It's a collection of logical instructions written in code that tells that inert hardware how to behave. If hardware is the engine of a car, software is the driver turning the wheel and pressing the pedal. Software isn't made of atoms, it's made of information. It can be copied a billion times without losing a single detail. And it doesn't wear out physically like a fan bearing or a leaking capacitor. While hardware provides the power, software provides the purpose. Without hardware, software is just.
Okay, my next question is, what are the main type of software?
All right, let's break it down properly. At the most basic level, software falls into two massive buckets: system software and application software. System software is the foundation. Think of it as the stage crew for a play. They aren't the stars of the show, but without them, nothing happens. This includes your operating system like Windows or Mac OS, which manages all the hardware, and utility software like disk defragmenters or antivirus programs that keep things running smoothly. Then you have application software, which is where we actually spend our time. These are the tools designed for specific tasks like Spotify for music, Chrome for browsing, or Photoshop for art. It's a huge spectrum from the deep invisible code that tells your CPU how to handle electricity, all the way up to the shiny buttons you click on a screen. Do you want to dive deeper into how those two actually talk to each other?
Okay, my next question is, what is system software?
Think of system software as the invisible manager of your entire device. It's the layer that sits right on top of the hardware, making sure everything is talking to each other correctly. Its entire existence is dedicated to creating a stable environment so that your other apps can actually function. If it weren't for system software, every single app you use would have to be written to talk to every specific piece of hardware in your machine, which would be an absolute nightmare. The biggest part of this is the operating system, like Windows or Mac OS, which handles the big stuff, managing your CPU, deciding how memory is shared, and keeping track of your files. Then you've got device drivers, which are like the translators that tell the OS exactly how to use a specific printer or graphics card. Finally, there are utility programs, the digital custodians that do things like scanning for viruses or cleaning up your disk. Basically, system software is the reason you don't have to be a computer engineer just to open a web browser. It's the steady, reliable foundation that does all the heavy lifting in the background without ever asking for a thank you.
So my next question is, what is application software?
Application software is where the magic actually happens for you, the user. While system software is the manager working in the background, application software is the tool you actually pick up to get a job done. Think of it like the difference between the electrical wiring in your house and the toaster you plug into the wall. The wiring is essential, but you can't make toast with a wire. You need the appliance for that. Application software is that appliance. It's designed to perform a specific set of tasks, whether that's something as simple as a calculator app or as complex as a full blown video editing suite. I'll give you a few more examples to show the range. You've got your productivity tools, the things that let you write a report or build a spreadsheet. And you have communication apps, the ones that let you send a message across the world in a second. And of course, there's entertainment software, from the games that transport you to another world to the streaming services that let you watch a movie. The fascinating part is that these apps don't have to worry about how to talk to your processor or how to manage your RAM because they just tell the system software what they need, and the system software handles the logistics. It's a tiered system that lets developers focus on the user experience rather than the raw electronics. Do you want to go deeper into how these apps are actually built?
My next question is, uh, what is coding?
Coding is basically the art of translating a human idea into a language that a machine can actually understand. Computers are incredibly fast, but they're also fundamentally simple. They don't understand English or Urdu or abstract concepts like make a button blue or play a song. They only understand on or off, one or zero. This is binary, the absolute bottom layer of everything digital. Now, you could spend your entire life typing billions of zeros and ones into a machine, but that would be a nightmare. And one single misplaced zero would crash the whole thing. Coding is the solution to that. It acts as the bridge between our complex, messy human thoughts and the rigid electrical reality of the hardware. It's where we use a higher level language like Python or Java, which allows us to use words and logic that make sense to us. Like, if this happens, then do that. A special piece of software like a compiler or an interpreter then takes that code and translates it down into the machine code that the CPU can execute. When you write a line of code, you're essentially creating a very strict, very detailed recipe. If you're coding a game, you're telling the computer, if the player presses the jump button, move the character's position upward on the y-axis, then apply a gravity constant to pull them back down. The computer doesn't know what a jump is or what gravity feels like. It just follows the mathematical instructions you've laid out. It's a weirdly satisfying blend of extreme logic and creative problem solving. You're architecting a digital world where the rules are whatever you decide they are, provided you can express those rules in a syntax the computer accepts. It's about breaking a massive, daunting goal down into tiny, microscopic steps until the machine can't possibly get it wrong. All right. It's easy to mix coding and programming up because they're so intertwined. But if coding is the act of writing the lines, programming is the entire process of building the machine that those lines actually power. Imagine you're building a house. Coding is like the actual masonry and carpentry. It's the physical act of laying the bricks, hammering the nails, and installing the pipes. It's the essential hands on work of translating a blueprint into something tangible. You can be a great coder, someone who can write a perfect, efficient block of logic without necessarily knowing where that block fits into the larger structure of a building. Coding is about syntax, precision, and getting the machine to accept your instructions without throwing an error. Now, programming is the role of the architect and the project manager combined. It's the high level thinking that happens before a single line of code is ever written. It starts with the why and the how. Programming involves identifying a problem, analyzing the requirements, and designing the overall logic and architecture of the software. It's about deciding which data structures to use, how different modules will communicate with each other, and how to ensure the entire system is scalable, secure, and efficient. A programmer doesn't just write code, they orchestrate a symphony of logic. They have to anticipate potential failures, design a strategy for testing and debugging, and constantly refine the blueprint as the project evolves. If you're programming a complex application, you're not just thinking about one function. You're thinking about the user journey, the database efficiency, and how the front end interacts with the back end. You're essentially mapping out a logical journey from point A to point B, ensuring that every turn is planned and every obstacle is accounted for. While coding is the act of translation, programming is the act of creation. One is about the language, and the other is about the story being told through that language. In a professional setting, a software engineer might spend a small portion of their day actually coding, but the vast majority of their time is spent programming, which means they're thinking, planning, and refining the architecture of the system. It's the difference between knowing how to spell a word and knowing how to write a novel.
My next question is,
My bad, did I lose you?
how is software
I'm
development?
lost. That's a great question. Software becomes interactive through what we call an event loop. Imagine the software is just sitting there in a state of active waiting, like a goalie in a soccer game, totally focused and ready for something to happen. It's not just running a straight line of code from top to bottom and then quitting. It's running a continuous cycle that constantly asks the system, did anything change? Did the user do something? When you click a mouse, press a key, or touch a screen, the hardware sends an electrical signal that the operating system catches. The OS then packages that signal into an event and tosses it into the software's event queue. The software sees that event, say mouse click at coordinates X and Y try, and immediately looks up what's supposed to happen in response. It might be a line of code that says, if this button is clicked, change the screen color to blue. The software then updates the display, and the whole cycle starts over, waiting for the next move. This happens thousands of times a second, which is why it feels like a seamless, living conversation between you and the machine. You're not just watching a movie, you're participating in a real time feedback loop where your input directly alters the state of the digital world. It's that constant dance of action and reaction that turns a static piece of code into a tool you can actually collaborate with.
Okay, my next question is, what does a software developer do?
All right, let's dig into this. I've been talking a lot about the tools and the logic, but a developer is the human at the center of all that. At the most basic level, a software developer's job is to solve problems using code. But if you actually look at their day to day, it's much less about typing and much more about thinking. They start with a problem, maybe something like, I want people to be able to order groceries from their phones. And they have to figure out how to turn that vague human desire into a functioning piece of software. That process usually starts with a discovery phase where they're essentially detective work, talking to users and stakeholders to define it exactly what the software needs to do. Once they have a plan, they move into the design phase, sketching out how the data will flow, what the user interface will look like, and how different parts of the system will talk to each other. Then comes the actual coding, but even that is a cycle of trial and error. They write a chunk of logic, it breaks, they spend 3 hours wondering why it's breaking, and then they find out it was a single misplaced semicolon. That's the debugging phase, which is probably where developers spend a huge chunk of their time, acting as a sort of digital forensic investigator. After the code is written and the bugs are squashed, they have to test it in every way possible, trying to break their own creation before a user does. Then there's deployment, where the software is actually released to the world, and then the process starts all over again with maintenance and updates. A developer is essentially a hybrid of an architect, a translator, and a puzzle solver, constantly refining and polishing a digital tool until it does exactly what it's supposed to do.
Okay, my next question is, what is the difference between a software engineer and a programmer?
All right, this is one of those things where the terms are used interchangeably every day, but there's a really interesting distinction when you pull them apart. Think of a programmer as a master craftsman. Their primary strength is the language itself. They can take a specific set of requirements and translate them into clean, efficient, and working code. If you have a problem that needs a script to automate a task or a specific feature that needs to be built, the programmer is the one who gets in the trenches and makes it happen. They are the ones who know the ins and outs of the syntax, the best way to structure a loop, and how to make the code run as fast as possible. Their focus is often on the immediate logic of the task at hand. But a software engineer, they are the architects. While they might also be great programmers, their focus isn't just on the code, but on the entire system. A software engineer doesn't just ask, how do I write this function, but rather, how will this function affect the rest of the application 3 years from now when we have a million users? They apply engineering principles to software, which means they're obsessed with scalability, reliability, and the long term life cycle of the product. They're thinking about how to design the system so it doesn't collapse under its own weight as it grows. They're managing the trade offs between speed and security and planning for how to maintain the software over time without it becoming a giant, tangled mess of code that no one understands. To put it simply, a programmer is focused on the act of creation, while a software engineer is focused on that act of sustainability. One is building the room, and the other is designing the entire skyscraper to make sure it doesn't lean or crack when the wind blows. In a lot of small companies, one person does both jobs, but in a big organization, you'll see these roles diverge, with engineers handling the blueprints and programmers handling the construction. Does that distinction make sense, or do you want to dig into a specific example of how that would look in a real project?
My next question is, uh, how does AI help in software development?
AI is basically like giving every developer a super powered assistant that's read every piece of code ever written. It's not just about writing lines of code, it's fundamentally changing how they approach the whole process. First, you have AI pair programmers. When a developer is typing, the AI is guessing, the next move in real time, suggesting entire blocks of logic before the human even finishes their thought. It's like having a co pilot who handles all the tedious, repetitive boilerplate code, freeing the human to focus on the actual creative problem solving. Then there's debugging, which is usually the most frustrating part of the job. AI can scan thousands of lines of code in a heartbeat to spot a pattern that looks like a bug or a security vulnerability that a human eye might miss after staring at a screen for 10 hours. It can then not only point out the error, but suggest the exact fix. It's also a game changer for documentation. Nobody likes writing the manual for their own code, but AI can analyze the logic and generate clear, human readable explanations of what the software is actually doing. Beyond that, AI is assisting in the testing phase. It can automatically generate hundreds of different test scenarios to try and break the software, finding edge cases that a developer might never have thought of. The really interesting part is that it's becoming a bridge for beginners, someone who knows what they want to build, but doesn't know the exact syntax of a language, can describe their idea in plain English, and the AI can provide a working prototype. It's moving the developer's role further away from being a translator and closer to being a conductor who orchestrates the AI to build the vision. Some developers are worried it'll replace them, but it's more like how the calculator didn't replace mathematicians. It just let them stop doing long division by hand and start solving bigger, more complex problems. It's taking the friction out of the process, letting them go from idea to functioning prototype faster than ever before.
So viewers, this is the session for Maya. Today we will meet you in another Maya session. तब तक के लिए अल्लाह हाफिज, पाकिस्तान जिंदाबाद.